The prefix intra, it means within. So we'll be discussing those forces of attraction or those bonds, chemical bonds, that are observed within a molecule. And there are actually two types of bonds that are being observed within a molecule. We have the ionic bond and the covalent bond. So prior to discussing those two types of bond, let us first understand why. Why do atoms form bond? Why do they participate no, sa chemical reaction? Now, as proposed by Gilbert Lewis, yan, that's Gilbert Newton Lewis, he proposed that atom is as it is at its most stable state if its outer shell is completely filled. For majority of the atoms, we could tell na yung outer shell is already completely filled if it contains already 8 surrounding electrons. Okay, so this proposal by Lewis comes to this theory, Lewis theory. So it states that an atom will tend to lose or gain or share electrons in order to achieve a completely filled outer shell. So meaning to say, the rationale behind lang why atoms tend to form bond is to attain stability. That's it. That's why they loses or gains electron forming ionic bond, or they share electrons forming covalent bond para ma-attain yung stable state. The same state with noble gases, yung mga nasa group 8 elements. Okay? So stable sila at that state if they achieve completely filled outer shell. Or this theory has come to be called octet rule. Octet, di ba? Oct means 8. Okay, so that is reflected to having 8 surrounding electrons on its outermost shell. Okay, however, this is not applicable to all of the atoms na kailangan talaga necessary to attain 8 electrons para they are considered stable at that state. Let's say, for example, hydrogen. Octet is not applicable. This rule is not applicable for hydrogen's outer shell, filled outer shell, because as we remember, diba, this is the first atom in the periodic table, so it has an atomic number of 1. Meaning to say, when we write its electronic configuration, it's only 1s1. Kasi it has only 1 electron, so it is being held by the lowest energy level, 1s. So para ma-attain ni hydrogen yung completely filled 1s, it will just gain 1 more electron. Okay, 1 more electron para completely filled niya ngayon yung S sublevel. So that would be forming hydride ion. Okay, so that becomes 1s2. The same electronic configuration with helium. Diba, yung mga atoms on the leftmost part ng periodic table, the reason why they participates to chemical reaction para ma-achieve nila yung mga completely filled outer shell parehas ng mga atoms na nasa group 8. Yung mga noble gases like helium, neon, krypton, ayan. So in the case of hydrogen, para ma-attain niya yung kaparehas na electronic configuration ni helium, it will gain 1 more electron during chemical reaction. Okay, so yung magiging electronic configuration niya ngayon is 1s2. Okay, so the same concept with lithium. Diba? Yung lithium is part of group 1A. Diba? Siya yung kasunod ng hydrogen sa grouping. Okay, hydrogen, then lithium. So, nasa sa group 1A. So, meron siyang valence electron na 1. Okay, yung 3 dyan is the atomic number. Pangatlo, si lithium sa periodic table. So, when we write its electronic configuration, it's 1s2, then 2s1. Okay, so ito yung valence electron ng lithium. Yung valence electron means electrons on the outermost shell. Ito yung outermost shell ng lithium. Yung last shell, kumbaga, the highest energy level na meron sa atom na lithium. Nandoon yung valence electron niya, which is only 1. Okay, so the same with hydrogen. Yung completely filled na outer shell na lithium is only 1s2. Meron man siyang extrang isa, kaya during chemical reaction, gagawin ng lithium, this is RO, okay, it will lose that one extra electron na meron siya. So, ito na yung na-lose niyang one electron. Kaya it will now carry positive 1 na charge. Kasi losing electron means forming cation. Plus 1 yun. Kasi isa lang yung nilose niya na electron. So, iyan na siyang i-give up para ma-attain niya ulit yung stable state kaparehas ni helium. No, kaparehas ni helium nga electronic configuration which is 1s2. Okay, so yan yung point ko kanina. Ang mga atoms, when they participate chemical reaction, they actually attain completely filled outer shell, the same with elements under group 8. Okay, group 8. So I want you to familiarize once again, no, the valence electrons ng mga very commonly encountered na mga atoms in chemistry. Okay, so just familiarize those commonly encountered na elements with their atomic number. And then last meeting, I told you to memorize their atomic mass. Diba? Sige. So let's have another example. Sodium. Sodium is also part of group 1, group 1A. Okay, so meron siyang valence electron na isa. So yung red dot dyan, yun yung valence electron niya. Sige, let's try to analyze kung isa lang ba talaga yung valence electron niya by writing its electronic configuration. So it's 1s2, 2s2, then 2p6, then 3s1. So these are the total electrons of the neutral atom ng sodium, 11 lahat. Base sa atomic number niya. Nasa periodic table naman yung atomic number. So 11 lahat for a neutral atom of sodium. Okay, now focusing on its last shell. Yung last shell niya is yung pinaka-highest nga N value, di ba? So 3s, yan yung outermost shell niya, nandoon nag-reside, occupying yung valence electron, which is only 1. So ito yun, pinakita natin in a form of red dot. Okay, so because naa siya'y extrang isa na electron, during chemical reaction, it will just lose that extra na electron or its valence electron. Kaya, always, di ba, yung sodium during chemical reaction, it will form an ion nga sodium ion. Okay? It loses 1 electron. So, losing 1 electron, that causes atom carry a charge of +1. So, ito yung na-lose na 1 electron of sodium. Kaya, yung magiging electronic configuration ngayon ng sodium na meron ng charge na +1 is itong box with color blue. Kasi na-lose na niya yung extrang isa. So, the same na electronic configuration ngayon ni neon. Try to check neon no, sa periodic table. yan po yung electronic configuration ng neon. Kasi yung neon, it has 10 number of electrons for a neutral, no, na neon. So, yan yung stable state and completely filled outer shell. How do you know na completely filled outer shell? Try to check the last shell this time of neon and the cation sodium. Yung 2, di ba? 2 yung highest energy level ngayon. Bilangin nyo yung nagre-reside in totality na ha. Nagre-reside na electron sa last shell. There are 8. And that's octet state. Diba? Sabi natin kanina, majority of the atoms, they attain stable state if na-attain nila yung octet, yung 8 electrons surrounding them, surrounding their outermost shell. Okay? Sige. Let's have another example. Let's say fluorine and also chlorine. In the periodic table, diba, they are part of group 7A. Part sila ng group 7A, kaya yung valence electron nila is also 7. Diba? Kung saan group sila na belong in the periodic table, yan din yung valence electron nila for A elements only. For A elements. So yung mga nasa S block and P block. Okay, so we have 7. So i-represent natin yung 7 valence electron meron yung halogens na fluorine at saka chlorine. Okay. Now try to observe, no, sige, iparehas lang natin yung orientation ng dalawang atom presented. Dito yung walang pares. Okay. Now try to check fluorine and chlorine. Merong isang unpaired electron. Okay, parehas sila, may unpaired electron. This is reflective to their electronic configuration as well. Try to check na yung fluorine has 9 atomic number, then chlorine 17. Pang 17 siya sa order arrangement ng atoms in the periodic table. So, isulat natin yung electronic configuration ng fluorine, 1s2, 2s2, 2p5. So, that's total of 9. Now, check the last shell. Yung last shell meaning highest N value. So, that's 2. Okay? Ilan yung nagre-reside na valence electron? Total of 7. Okay? So, that's reflective to its group number and its valence electron. Total of 7 yung valence electron ng fluorine. How about chlorine? Sulat natin yung electronic configuration. 1s2, 2s2, 2p6, 3s2, then 3, ilan na yan? 6, 10, 11, 12, kulang ng 5 para 17 lahat. 3p5. Okay, so total of 17. Check again the last shell. So this time, yung last shell is 3. Yung third shell. Yan yung last shell surrounding the atom, chlorine, and andoon nagre-reside yung outermost electron or what we call the valence electron. Ilan na lahat? 7 din. Okay, so reflective lang. Sa group number, nasa group 7 siya, and that's equivalent to the valence electron. Now, observe nga sa kanilang p orbital, tingnan yung p orbital, 5 lang yung electron occupying sa kanilang p orbital. Yung sa last, yung nasa last shell nila. Let me ask you, ilan ba dapat ang kayang ma-hold, maximum number of electrons kayang i-hold ng p sublevel or p orbital? Sige, try to recall. Ilan ba? Kung ang S hanggang 2 yung maximum electron na kaya niyang i-hold, ilan ba yung kayang i-hold ng isang p orbital? Yes, anybody from this class? Okay. Yes, very good. Total of 6. So, kulang ng isa. So, kung atong i-represent, if this is the p orbital, di ba tatlo sa isang sublevel na p, tatlo yung orbital sa p sublevel. And it could occupy, kung completely filled nga p orbital, 6 lahat yung kayang i-hold na electrons ng isang p sublevel. Kaya, if you try to realize here, 5 lang daw ang nag-occupy. So, merong isa dyan nga p nga unpaired, walang partner. Okay? That makes fluorine and chlorine not yet stable. Kaya during chemical reaction, gagawin nila para ma-attain nila yung stable state, ma-attain nila yung completely filled na outer shell for their p orbital, magigain sila ng one more electron. Okay? Para makumpleto, no, yung outer shell, ma-completely filled yung outer shell. Kaya nga always ang fluorine and chlorine, they will carry -1 nga charge kasi kulang ng isa lang na electron, 'di ba? Sa kanilang p orbital. Okay, so that will become chloride ion and fluoride ion. Okay, so at this state, they now attain octet. Octet na if they carry a -1 charge. Okay, so yung magiging electronic configuration ngayon ng fluoride is 1s2, 2s2, then 2p6 na. The same with neon. Diba? The same with neon. Okay? How about chlorine? Ay, sorry. Ayan. So, for chlorine, yung ayan. For chlorine, yung chloride rather. This is already chloride kasi may -1 na charge. So, yung electronic configuration niya, attaining completely filled outer shell, 3s2, then 3p6 na. Okay, so completely filled na ngayon. Yung third shell niya, may 8 electrons na. 8 electrons sa second shell, last shell ng fluoride. Then for chloride, third shell. Yan yung highest or last shell meron sa atom na chlorine. Okay, so ito attaining the same electronic configuration with argon. Okay, so yan lang yung rationale behind why atoms tend to form bond. Okay, sige. So this time, let's talk about the two types of intramolecular forces of attraction. We have the ionic bond and later on, covalent bond. So yung ionic bond, as the term suggests, this bond is being formed upon interaction of the ions. Di ba, meron lang tayong dalawang types ng ions, cation, anion. So kapag nag-react, interact, yung positive charge, negative charge, then that will form ionic bond. And the compound, we call it ionic compound. So between ions of opposite charge, yun, yung positive charge, the cation, negative charge, the anion. Or there are also other references. Ngayong definition ng ionic bond is attraction between metals and non-metals. Okay, kasi yung metals are the ones that forms cations. Non-metals, sila yung nagfo-form ng anions. Okay? So, a good example, sodium chloride, magnesium chloride. Sige, i-represent natin para makita lang paano na-form yung ionic bond. As we recall, sodium is a metal. Okay? And meron siyang valence electron, isa. Because it is part of group 1A. That's how we represent its valence electron. By the way, it's only the valence electron that participates in chemical reaction, chemical bonding. Yung other electrons, yung mga nasa core portion or yung mga nasa lower energy level na electrons ng atom na yan, they do not participate sa chemical reaction. Valence electron lang. They are the ones that participate in chemical bonding, chemical reaction. Okay, going back to sodium, once again, it has 1 valence electron. How about chlorine? It has 7. valence electron as we represent it earlier. O, tingnan, if you try to analyze sodium, meron siyang extrang isa, so it will just donate electrons to chlorine. Kasi yung chlorine, kulang siya ng isa. So it will gain electron here. Nakuha? Si sodium, may extra siyang isa, di ba? Any metals during chemical reaction, they will give up electrons because they have extra electron. Ang mga non-metals, they will gain electrons kasi may kulang sila. So they prefer to accept electrons. So with that, para ma-attain nila yung stability, magkakaroon lang ng transfer of electrons. Transfer of electrons, the sodium will donate electron, chlorine here will accept the electron given by sodium. And that will form a bond. Okay? Yung bond na yan, ang tawag natin, ionic bond. Because the interaction it happened between opposite charges. Okay? Sodium ion and chloride ion. Now, another example is magnesium chloride. Okay. Magnesium is part of group 2A sa periodic table. So, meron siyang dalawang valence electron. Again, yung chlorine, part siya sa 7A. So, meron siya each 7 valence electron. So, ito yung 7 valence electron. So, merong unpaired electron, yung chlorine. So, kulang siya ng isa. Whereas, yung magnesium, meron siyang extrang dalawa. So, para ma-attain nila both yung stability, transfer of electrons yung gagawin dito. Okay? So, yung magnesium, yung isa niya, idodonate sa 1 chlorine. Yung other electron, valence electron, it will be donated sa other naman nga chlorine. So, ito, they will just accept. Yung both chlorine, they accept electron. So, kapag may donate, then accept electron, transfer of electrons yun. So, that's the concept of ionic bond. So, ito no yung magiging bond that connects magnesium and chlorine in this compound of magnesium chloride. Okay, so at that state, they already attain octet. Okay, octet state. Sige, let's focus more on the second type of chemical bond observed sa intramolecules. We call it covalent bond. And this is the type of bond that is commonly observed sa mga organic molecule. Okay, so how does covalent bond is formed? So it is formed by simply sharing of electrons. And this happens between nonmetals to nonmetals. Okay, kapag nag-interact yung nonmetal and nonmetal, di ba as we mentioned earlier, ang mga nonmetal, they have unpaired electron. Kulang sila ng electron. Okay, para ma-attain nila yung completely filled outer shell. So, para mabuo yung covalent bond, they will just tend to share it kung ano yung meron sila. I-share lang. Walang losing of electron, walang gaining of electron. They will just share electrons para pantay sila. Okay, kasi puro non-metal ang being bonded. O, parehas man sila kinulang. I-share na lang nila yung unpaired electron meron sila. Example, ito pa ulit-ulit no, yung chlorine. This is actually chlorine gas, hydrogen gas. Diba? Kanina, when we represent chlorine atom, meron siyang unpaired electron having 7 valence electron. Ayan. So, another chlorine. So, ito naman yung unpaired electron niya. O try to observe. Class, meron silang unpaired electron, parehas sila kinulang. So para ma-attain nila yung stable state, yung octet state, they will just share it. Okay, share the electrons na meron sila. Okay, so upon sharing electrons, they will form covalent bond. So ang tawag dito sa bond na to is a covalent type of bond because there's only a sharing of electrons that happened. Okay, so they now attain octet state. By the way, whenever you observe a formation of bond, always remember that two electrons there are shared. Equivalent to two electrons yung nandyan sa isang bond line. Okay, sa isang bond line, equivalent yan sa two electrons. Ito isa, pangalawang electron. Okay? Hydrogen, the same concept. Diba? Hydrogen kanina when we represent it earlier, na sila'y only one valence electron, one unpaired electron. So, para ma-attain niyo yung stable state, it should have at least two, di ba? Yan yung maximum na. Maximum na electrons na kayang i-hold ng atom or outer shell ng atom hydrogen. Kaya they will just share that. So that is equivalent to two electrons. So each hydrogen now holds two electrons. And yan yung completely filled outer shell ng hydrogen. So always remember nga, si hydrogen in any molecules, isa lang dapat yung bond that surrounds hydrogen. Kasi sa isang bond, dalawa na yan na electron. And at that state ulit, kung meron ng dalawang nag-surround na electron sa hydrogen, completely filled na yan si hydrogen. Yung outer shell niya, rather. Okay, hydrochloric acid. So, yun din, hydrogen with chlorine forming covalent bond. Ito yung covalent bond. So, they now attain stable state. Si chlorine dito, octet, yung hydrogen completely filled din. Although not octet. Hindi naman niya kaya yung 8, 'di ba? Yung 8 electrons kasi meron lang siya is 1s. So hanggang 2 electrons lang. Okay, for hydrogen. Okay, another example, water. Now with regards to water molecule, 'di ba, it has oxygen in it. So nasa yung oxygen. And as we observed no, sa periodic table of elements, it is part of group 6A. So, meron siyang valence electron na 6. 1, 2, 3, 4, 5, and 6. Now, try to observe. Meron siyang unpaired electron, 2. Walang pares na electron, unpaired electron. So, with that, para ma-attain na yung stable state, it will form 2 equivalent covalent bonds. Okay? Para may partner ngayon, yung dalawang unpaired electron. So good thing sa water molecule, merong dalawang hydrogen. So let's say itong kulay red, ito yung sa hydrogen. So each of the hydrogen, dalawa man, no? Dalawa yung hydrogen sa water molecule. Each hydrogen may unpaired electron din. So they will prefer to share kung ano yung meron sila. Okay, forming 2 covalent bonds. So sulat natin how the electrons are being shared here. O, para hindi kayo ma-confuse, yung mga color block font, yan yung kay oxygen. Yung color red, yan naman yung kay hydrogen. So meron tayong dalawang shared electron. When you say shared electron, it's already the bonding electron, and we usually represent the bonding electrons or the bonding pairs in a form of lines, di ba? So, ito yung formation ng bonding lines or the covalent bond. between oxygen and hydrogen. So yan, yung dalawang bond. Again, yung kulay red kay hydrogen. Ito naman kay oxygen yung color black. Okay, so dalawang bond yung kayang i-form ni oxygen sa chemical reaction para ma-attain niya yung pinaka-stable state niya. Okay, so take note of that. It forms two covalent bonds with how many lone pairs? 1, 2. Lone pairs ang tawag dyan. Yung hindi nakabond, not shared, those are lone pairs of electron. Kapag pair, that's equivalent to 2 electrons. Kaya in a box, sa isang pair, di ba may dalawang dots, that's 2 lone electrons. Okay, so just be mindful, don't be confused sa terms. Kapag electrons, lone electrons yung tinatanong, it's the dots. Yan yung electrons. Kung pares, syempre sa isang pair, that's equivalent to 2. No? So 2 electrons. So there are 2 pairs, 2 lone pairs. Kapag oxygen oxygen. Sige. Let's proceed to another example. Ayan, ammonia. NH3. NH3. Sige, let's try to illustrate how nitrogen forms covalent bond and ilan yung pinaka-stable niya na number of covalent bonds. So nitrogen is part of group 5. Okay, so meron siyang limang valence electron and tatlo yung unpaired. Walang pares. Okay, tatlo yung unpaired. Therefore, para ma-achieve niya yung stable state, it will form 3 covalent bonds. Kaya sa molecule na ammonia, NH3, tatlo yung hydrogen. Okay? So it will just form 3 covalent bonds with hydrogen. Okay, so this is how the shared electrons are formed. Ayan, let me show it. Yung color red ulit kay hydrogen, color red. Okay, so meron kayong tatlong shared electrons na ma-observe. 1, 2, 3. Shared yun. When you say shared, you have 2 atoms sharing electrons, sharing a bond. So, i-form natin yung bond yung tatlong bond. So, you have lone pair here, and ito yung tatlong bond towards hydrogen. Okay, yung kulay red na dots, kay hydrogen yan na electron kanina. Color blue na dots, yan yung limang electrons meron si nitrogen. So stable na at that state si nitrogen including hydrogen. 'Di ba? Sinabi ko kanina as mentioned, hydrogen isa lang dapat yung bond kaya niyang i-form. Okay? So for nitrogen, yung total number of bonds na kaya niyang i-attain, i-form at its stable state is tatlo. So 3 covalent bonds for nitrogen, and there's a lone pair. How many lone pair? 1. 1 lone pair. Okay? Sige, let's have last one example. Ito. CH4, or that's the simplest na organic molecule. Let me erase this part. Ayan. Okay. So let me write it again. Last example So it contains carbon in it. So carbon, try to check in the periodic table, it's part of group 4. Okay, so meron siyang 4 na valence electron. And in the molecule methane, 4 yung hydrogen. Okay, so attaining stability or attaining completely filled outer shell, it will just share all its valence electron to hydrogen. Okay, forming 4 covalent bonds. So ito yon. So you have 4 valence electron for carbon. Then ito yung kay hydrogen. So nag-share lang sila. ng electron kung ano yung meron sila. So, 4 ang shared electrons na ma-observe natin, and that's equivalent to 4 covalent bonds. So, ito yung 4 na covalent bonds. Okay? So, always remember na ang carbon, if you encounter later on, no, mga structure na organic molecule, tapos merong carbon in it, talagang 4 covalent bonds yung kayang mabuo ni carbon. Walang lone pair. No lone pair observed. Okay, never will happen nga magkikarry ng lone pair ang carbon. At that state, hindi siya stable at that state. Okay, so lahat dapat i-share niya. Okay, forming 4 covalent bonds. Okay, so to summarize, always take note for nitrogen, stable number of bonds niya ulit is 3 covalent bonds with 1 lone pair. Take note of that kasi you will apply this later on in writing Lewis structure. Then for oxygen, 2 covalent bonds with how many lone pair? 2. Okay. And finally, carbon, 4 covalent bonds without lone pair. No lone pair. How about hydrogen? Ilan lang ulit yung covalent bond na kaya niyang i-form? Sige, just to assess if you are still following. How about hydrogen? Ilan yung bond, covalent bond, na kaya niyang i-form? Sige, go ahead. Your turn. Excuse me. Anybody from the class? Sige, I will just call names. Yes, Miss Dianalan. How many covalent bonds? Pinaka-stable na number of covalent bonds for hydrogen? Yes? Is she not around?
Yes, ma'am. Sorry.
Yes. How about Sander Galendez?
1 covalent bond po, ma'am.
Okay, 1 covalent bond. No lone pair. Okay, no lone pair. That's the most stable number of bonds that a hydrogen can form. Okay? Sige, let's proceed to the subtypes ng covalent bonds. So we have two types ng covalent bonds. So let's reinforce the concept kapag covalent bonds between non-metals lang yan. Non-metals. So meron tayong dalawang types ng covalent bond. Non-polar, the other one is polar. Okay. So non-polar if equal yung sharing ng electrons. As we recall, etong bond na to that connects non-metals together, nangyayari dyan is sharing of electrons lang. Now, the moment nga equal yung sharing ng electrons, then that type of bond, we call it non-polar. How do we know if equal yung sharing ng electrons? If identical atoms are being bonded. That's the most common example ng non-polar covalent bond. If the bond is formed between identical atoms. Kasi walang lamangan sa electron negativity property. Parehas sila ng extent to pull electrons towards themselves. So, equal yung sharing ng electrons. Okay? So, good example, ayan. Puros identical atoms, di ba, ang bonded. So, equal lang yung sharing ng electrons. However, there are few examples ng non-polar covalent bond na hindi parehas yung non-metals being bonded. Hindi parehas. So, non-identical atoms. Example, carbon and hydrogen. Diba? Hindi parehas. But we still consider this type of bond as non-polar. Bakit? It's because the electronegativity difference is konti lang. Okay, konti lang yung difference sa electronegativity. So somehow walang uh, walang grabe mataas na gap between the pooling or attracting electrons. Okay, so somehow equal pa rin yung sharing ng electrons. In fact, these are not no electronegative atoms present. So as long as walang that's highly walang highly electronegative atoms present between bonded atoms na puro nonmetals, then we could tell nonpolar pa rin yung covalent bond. You can also check for the electronegativity difference. By the way, yung electronegativity, that's a property of any atom that uh, attracts electrons towards itself. So a property of atom to attract or pull electrons towards itself. Okay? So, yan yung electronegativity. And kung wala namang presence ng highly electronegative atom, then walang lamangan pa rin sa attraction of or pulling of electrons. So, just like carbon and hydrogen, in the periodic table, you can check naman the values ng electronegativity nila. For carbon, it's 2.5. For hydrogen, 2.1. So it still falls under this range, 0.4. So it's nonpolar. And this is the type of bond na commonly observed sa mga organic molecule. May carbon tsaka hydrogen. Okay, hydrocarbons. Kaya nga when we look for organic molecules, hydrocarbons nga bonding is commonly observed, and that's nonpolar. That makes them nonpolar nga portion sa organic molecule kapag may carbon-hydrogen bonding. Again, this is non-polar bond. Carbon and bromine nga bonding. This also falls under this range, no? Yung electronegativity difference nila. Okay, you try to check 2.5 minus 2.8, so 0.3. So it falls under this range pa rin sa non-polarity. Okay, so for you to easily identify if it is non-polar covalent bond, kahit magkaiba yung atoms no being bonded, you just check if meron ba or walang highly electronegative atom. So just make sure nga walang highly electronegative atom present. What are examples of highly electronegative atom? Yung fluorine, oxygen, nitrogen, at saka yung halogen na chlorine. Just take note of this four. Okay? Kapag nakita nyo hindi parehas na non-metals being bonded, pina-identify kayo kung non-polar ba or polar. Tingnan nyo lang kung walang highly electronegative atom. That is non-polar nga bond. Okay? Sige. So, if ever naman may makita kayong highly electronegative atom, yung mnemonics na phone, meron ito sila. Okay? Then, that's the time you could conclude nga polar yung covalent bond. Example, chlorine. Ang chlorine being bonded to hydrogen. Now, as we refer to this list no ng highly electronegative atom, andyan man sa listahan si chlorine, then that's highly electronegative atom. So yung pool of electrons is lamang kay chlorine. So hindi pantay ngayon yung sharing of electrons, hindi equal yung pagka-share ngayon sa electrons kasi mas marami, mas grabe ang pool of electrons papunta kay chlorine being a highly electronegative atom. Okay, and you can also check the electronegativity difference if it falls between 0.5 to 1.7. This is the cutoff hanggang 1.7. Kasi greater than 1.7 nga electronegativity difference, that's already for ionic bond. That's not covalent bond anymore, but it's ionic. Okay, kung greater than 1.7. Kaya may cutoff, no, yung polarity level sa mga covalent bond. Okay? Another example, nitrogen bonded to hydrogen. So, di ba, nitrogen is a highly electronegative atom. It is being bonded to hydrogen. Hydrogen is least electronegative. Okay, so that's polar, highly polar. The same with oxygen bonded to hydrogen or in a water molecule, diba? That's water molecule. So that's highly polar. Okay, so unequal yung sharing of electrons. Okay, can you show a thumbs up if you understand the concept on polar and non-polar covalent bond? Okay, so let's try to have a comprehension check. I will just answer one item, then during your independent study, you can answer the rest. Sige, let's try uh, the first uh, the first problem. You are asked to identify which is a more polar bond. You can make use of the chat box to answer and participate. Okay, which is more polar? Again, sabi natin dito, polar ang isang covalent bond if may presence of highly electronegative atom. Bonded siya sa least electronegative atom. So letter A or letter B for item number 1. What's your answer? Go. So pinakita naman yung bond. Okay? Which is a more polar nga bond. The one with chlorine or the one with carbon bonded to hydrogen. Okay, that's it. So that's how you identify. Para mapadali yung pag-identify nyo sa polar ba or non-polar covalent bond. So you do the rest. Okay, with this sample problem, you just have to write symbol partially positive or partially negative. This is just to show the direction of polarity. Saan ba dito ang highly electronegative na atom based sa shown bonded atom. So sa given example, between carbon and oxygen, as we all know, di ba, oxygen is part of highly electronegative atom. So siya yung mag-carry ng partially negative na sign. Kasi yung pool of electrons is more on papunta sa direction ni oxygen. Papunta sa direction ni oxygen. So, ito yung concept sa problem na to. Identifying lang sino yung partially positive, sino yung partially negative. Sige, you try letter B. Which do you think will carry partially negative nga sign? Base sa being shown nga bonded atom. Sige, your turn. You can make use of the chat box. Sino dyan yung partially negative? The one that is highly electronegative atom. Yan yung partially, that will carry the partially negative atom. Yes? Is it which of that atom being bonded? Yeah, you just have to choose. So 50-50 lang. Okay? Sige. Carbon or nitrogen? Okay. It's nitrogen. It will carry a partially negative sign. Okay, so partial lang yung gagamitin dito kasi covalent bond man, wala man transfer of electrons na nangyayari. Unless it is ionic bond, we have to indicate na full negative pole. The other one is a full positive pole. Okay, so you do the rest. So this time, let's talk about Lewis structure. Kasi sa other section, we were able to discuss writing Lewis structure. So in the previous slides, we were able to understand why atoms form bonds simply to attain stability, to attain octet state. So this time, let's try to apply the concept of octet rule in writing Lewis structure. Now, by the way, ang discussion on Lewis structure, we will be drawing this time. Okay, you have to know how to draw. Lewis structure, learning Lewis structure is a must here for you to start, no? Parang first step siya to draw organic molecules or visualize a molecule. You have to know how to convert molecular formula to its Lewis structure. That's the first step in our analyzing or writing complex structure. Okay. So what is a Lewis structure? A Lewis structure, it shows electron dot symbols for atoms, or technically, yung makikita natin dito is the correct position of atoms in a molecule. The correct positioning of atoms in a molecule or in a polyatomic ion. Okay? At the same time, makikita din natin yung correct placement of shared electrons and unshared electrons. Okay, when you say shared electrons, that's the bonding electrons, and it is being shown using lines. Kapag unshared electron naman, these are also the lone pairs, and they are shown using pair of dots. Okay? Sige, let's have these steps. By the way, ang first natin i-learn to write Lewis structure are those molecules or species that obey octet. Those that obey octet rule. Okay? Then, sa separate discussion na yung writing Lewis structure that are exception to the octet. Okay? So, kapag octet, again, the atom should have 8 electrons surrounding or filling the outermost shell, or for hydrogen, 2 electrons. Okay? 2 electrons. That's the filled state, di ba, ng hydrogen. Okay? So what's the steps, no, in writing Lewis structure? First step is know the placement of the atom, which should be the center and the surrounding atom. Take note that the central atom sa isang Lewis structure is the atom with the lowest electronegativity. Okay? So let's say, for example, the compound or the molecule given, this is a molecule, is nitrogen trifluoride. You have to decide saan dyan yung central atom, saan dito yung surrounding atom. Take note, the atom that is written as the central atom should be the one with lowest electronegativity. Okay, so going back to periodic trend, as you recall, no, your stock knowledge on periodic trend, talking about electronegativity, ang electronegativity trend natin is going to the right and going up, increasing yung electronegativity ng atom. As again, going to the right and going up, increasing yung electronegativity ng atom. So, mga elements na nandito are said to be highly electronegative. Okay? Now, sabi natin dito sa first step, ang atom that should be placed in the center should be the one with lowest electronegativity. So, nasaan yung mga lowest electronegative atom? Yung mga nasa left side ng periodic table and bottom part. Okay? So, kabaliktaran ng trend na kulay pula na sinulat ko. It should be going to the left, going down. That's the time makikita natin yung mga atoms na least electronegative. So, between nitrogen and fluorine, you can check the periodic table. Nasa leftmost part man, di ba? Leftmost part, si nitrogen. So, siya yung magiging center atom natin dito. Then, the rest na mga atom sa molecule, surrounding sila. So, it's up to you saan nyo ilalagay, basta kay nasa surrounding ng nitrogen, being the central atom. Okay, another example. a polyatomic ion na carbonate. Okay, so carbonate. Polyatomic ion naman ito kasi it carries a charge. Okay? So, first step ulit, which should be the central atom? Okay, is it carbon or oxygen? As we all know, oxygen is highly electronegative. Sabi natin dito, ang center atom should be lowest electronegative atom. So, it should be carbon. Then, kayo na bahala saan nyo ilalagay yung tatlong oxygen. Basta kay surrounding siya. Ano yung magiging position niya ba? So, it's up to you kung dito nyo ilagay or sa baba lahat. Basta kay nasa surrounding ng carbon being the central atom. So, that's the first step. Deciding which should be the center and the surrounding atom with a given molecule or polyatomic ion. If it is a polyatomic ion, you have to write it inside a bracket. Kapag yung binigay na halimbawa is charged no nga entity, placed it inside a bracket, then place the charge outside the bracket. Second step. Okay, sige, move forward. Ang second step, after deciding the placement of the atom, you have to total the number of valence electron. That's why you really have to be familiar with the valence electron ng pinaka-common na atoms encountered sa organic molecule. Okay? So how do you compute the number of valence electron in a molecule? You simply add all the valence electron ng atoms given. For example, 'di ba, nitrogen trifluoride yung given kanina, and the other one is carbonate ion. So yung molecule between the two is nitrogen trifluoride kasi walang charge. You will easily know if it is a molecule, if it's a combination of two or more atoms tapos walang charge. Molecule yun. It's a stable molecule. So compute nyo yung total valence electron. Nitrogen, ilan yung valence electron niya? 5. For fluorine, valence electron niya 7. And sa molecule given, tatlo man yung fluorine. So times 3. Okay, times 3. Then you simply multiply and then add. Okay? So that's total of 26 electron. I-add nyo yan. That's all about step 2. You simply add all the valence electron. Okay? Now, with regards to the polyatomic ion naman, di ba, it has already charge presented. So, after you add up, say, add muna natin ang total valence electron ng mga atoms observed sa carbonate. Carbon has 4 valence electron, whereas ang oxygen, di ba, 6 yung valence electron niya. So, times 3. Kasi tatlo yung oxygen presented in carbonate. Okay? So, you have 4 for carbon, total of 18 for oxygen. Kasi nga, nag-times 3 tayo. Tatlo man yung oxygen. Okay? So, 18 plus 4, 22 electrons. That is not yet the final total valence electron for this given polyatomic ion. Kasi, meron siyang charge. You have to reflect that charge sa total number of valence electron ng given ion. If it carries a negative charge, remember, it means gaining electrons yun. Kasi anions during chemical reaction, the reason bakit nag-carry sila ng negative charge, it's because nag-gain sila ng electron to attain stable state. That's why if it's a negative charge, you have to add electron. Whereas if it carries positive charge, what does it mean kapag cation, 'di ba, losing electron? So kailangan mong mag-subtract out of the initial total na valence electron. Okay, sige, let me ask you. From 22, should I add or subtract 2 from 22 electrons. Sige, yung isasagot nyo lang is add or subtract. Okay, very good. So you add how many? 2. Kasi sabi dito, 2 negative. So 2 electrons. So that's total of 24 electrons. That is all about step 2. Inyuha lang yung i-compute ang total number of valence electron. Okay? For molecules, diretso ra add. For polyatomic ions, after you add, you have to reflect the charges. Kung negative charge, add. Kung positive charge, you have to subtract. Okay, do not forget the concept on forming cation and anion. Kapag cation, losing electron yon, anion, gaining electron. Okay? Sige, so you have to familiarize the valence electron. Common lang, yung common. Okay? Sige, third step. So far na learn na natin yung first step. Ang first step is placement. Sige, sulat natin yung placement. So nitrogen trifluoride, yung placement natin kanina, 'di ba, is nitrogen being the center, fluorine surrounding. Sa carbonate, carbon being the center, and then oxygen, kayo bahala sa orientation ng surrounding. Pwede natin ibahin. Pwedeng sa taas naman. Ayan. Basta kay surrounding yung oxygen. Okay? Then yung second step, total. Diba? Ang total natin dito sa number of valence electron for this molecule is 26. Dito naman is 24 ba yun? Diba? 24 electrons. So, yun yung second step. Sige, proceed with third step. Ang third step is drawing single bonds. You draw single bonds connecting the central atom towards the surrounding. So magsisimula ka sa central atom papuntang surrounding. I-connect mo lang yung center to surrounding, center to surrounding. That's the purpose of single bonds. And of course, as we recall, sa isang bond, ilan ulit yung electron being shared? 2 electrons yan. Since in the given example, we have now presented 3 bonds. That's 1, 2, 3 bonds, di ba? And sa isang bond, dalawa yung electron, 6 electrons na yung na-present. Tama ba? Na-present na natin yung 6 electrons. Given nga 3 bond yan. Okay? So 2, 4, 6 electrons are being presented. So you have to subtract. I-subtract mo yung na-present natin na single bonds out of the total. Okay? Para later on, correct yung ma-distribute natin na number of electrons as lone pair. Okay? So 20 na lang yung electrons na natira out of the total. Okay? So kailangan nyo i-subtract yung na-present nyo na mga electrons using bonds. Okay? So that's the third step. Okay? Now for carbonate, ganun din. 3 yung bonds na na-present. Total of ilang electrons yan na na-present. So 6 din. So minus 6 from 24. So that's 18. Okay? Yan yung remaining electrons. Okay? That's the purpose of third step. You have to find out the remaining number of electrons after you draw single bonds. Okay? Kapag naguhit ka ng single bond, i-minus nyo yan sa total. Okay. And fourth step naman, you will now distribute the remaining electrons. Diba meron na tayong remaining electrons? Ito yon, 20 for nitrogen trifluoride, 18 for carbonate. Ano yung gagawin sa remaining electrons? You have to distribute them in pairs. So by partner natin siya i-distribute sa mga atoms presented. Saan ka magsisimula mag-distribute? You have to distribute first to the surrounding, then i-last natin yung center. Bakit sa surrounding una mag-distribute? Because the surrounding atoms are highly electronegative atoms. True to say, kasi tingnan niyo yung mga surrounding atoms. Fluorine dito. Fluorine is the most electronegative atom. Oxygen is another electronegative atom. So, sa kanila una mag-distribute ng electrons. Ma'am, pila man atong i-distribute, make sure that they attain octet. Okay? However, for hydrogen, dapat 2 electrons lang, 'di ba? Yung kaya niyang i-hold. So dapat kung makita mo na si hydrogen may isang bond na, no need to distribute anymore, no? Electrons kay hydrogen kasi yung kaya niya lang talagang i-hold isang bond. Never will happen nga meron siyang lone electrons yung hydrogen. Basta meron na siyang isang bond, stable na at that state si hydrogen. Okay? So wala namang hydrogen sa given example. No? So we have to make sure nga each of these atoms attain octet. Octet meaning 8 electrons. So i-distribute natin yung 20 electrons pantay nga tig-8 yung each atom. So for fluorine, each fluorine parehas raman yung surrounding, no? Kulang sila ng tag-6, no? 6 electrons. Kaya you distribute 6 here. Kasi meron ng dalawa, di ba dito? This is already 2 electrons. So, kulang ng 6 para ma-attain dito ni fluorine yung octet. So, dito din, 6. So, octet na dito, then 6. So, ilan na lahat yung na-distribute na electrons? 6, 12, 18. So, 18 na. Out of 20, naka-distribute na natin ng 18 electrons. So, pilay nabilin? Duha. So, asa man mapadulong ang duha ka electron. Since octet na ang surrounding, that's the time you proceed to the center atom or central atom. So, yung dalawang natira, out of 20, it will be distributed sa center atom or central atom. Okay? So, now try to check if all of the atoms attain octet. O, tingnan nyo yung, okay naman tayo sa fluorine, surrounding fluorine. They are now surrounded by 8 electrons. How about the center, nitrogen? O, tingnan nyo, meron na siyang 3 bonds dito. 3 bonds is equivalent to how many electrons? That's 6. Diba? Sa isang bond, dalawa kasi sa isang bond. Dalawang electron rather sa isang bond. So, 2, 4, 6 na yan. Then, yung pang-8, ito yun, 7 then 8. So, it now attains octet din, yung nitrogen. Okay? Can you show a thumbs up if you understand the writing of Lewis structure for singly bonded nga molecule? Okay, so that's good. How about yung carbonate? Okay. Yung sa carbonate naman, sige, ato siyang ipadayon na ang distribution of electron. So we have 18 remaining electrons, i-distribute natin. So for oxygen here, kulang ng 6. Okay, ito yung pang-8, 7, 8. Then 6 ulit. So 6, 12 na. 12 na yung na-distribute out of 18. Okay? Then yung pang-18, ito, dito yung natirang 6. Okay? So, octet at this state, yung mga oxygen sa surrounding. Diba? 18. Total of 18 yung na-distribute natin. 6, 12, and then 18. Yung mga color block. Okay, color block nga dots. Yun yung total of 18 na remaining. So, they now attain octet. Octet. Bakit? 8 yung surrounding electrons for each oxygen, including na itong bond. Now, my question here, does carbon attain octet? Yes or no? Yes or no lang yung isagot. Yung carbon, yung central atom, na-attain ba niya yung octet? Yung 8 surrounding electron, meron si carbon. Focusing on carbon ha. Tingnan niyo yung surrounding na bonds ng carbon. Okay, hindi. Hindi, kasi ilan lang? 2, 4, 6 lang yan, no? 2, 4, 6 electrons. So, kulang ng dalawa. That's the time you have to add, medyo malayo pa, yung 5th step. So, ito yung 5th step class. Wherein, yung if ever, sa tingin nyo, when you write the Lewis structure, hindi na-attain ni central atom yung octet, gagawin nyo is you change the lone pair from the surrounding into another bonding pair. Okay, yun lang po yung gagawin. Okay, sige, balikan natin yung sample. Ayan. Okay. Since you were able to identify na si carbon hindi niya na-attain yung octet, ipasok niyo yung fifth step. Sa fifth step, you have to get, no? Or change the lone pair. This is a pair. This is a lone pair. From the surrounding atom, gawin nyo yung bonding pair. Gawin nyo yung bond line towards the center atom. So, inyo siyang i-change, you erase that, yung isang pair, and gawin mo siyang bond line. And yung bonding line, it should connect towards the center atom. Okay? Ma'am, asa man may magkuha nga surrounding atom. In this given example, since parehas lang oxygen, equal lang lahat yung lone pair, no? Parehas lang lahat. So kahit saan dyan, pwede kang change ng lone pair into a bonding pair towards the central atom. Then you check this time if na-attain na ba nila yung octet. Yung oxygen dito, kung saan nagkuha tayo ng lone pair, ginawang bonding pair, naka-octet state pa rin siya. Try nyo bilangin lahat ng electrons that surrounds oxygen, yung nasa rightmost part. Diba? Meron siyang dalawang bonds, so that's equivalent to 4 electrons. So 4 electrons na yan, 5, 6, 7, and 8. So octet yan at that state. How about carbon dito? Tanong ko sa inyo, ang carbon ba this time, yung central atom, na-attain na ba niya yung octet? Yes or no? After we form multiple bond or a double bond, no, between carbon and oxygen. Yes or no? Sige. Para i-dismiss ko na yung class kasi tapos na yung discussion. Yes or no? Okay. Okay. So that's it. That's how, no, you write Lewis structure. So for singly bonded nga mga atoms sa isang molecule, you can make use of the first 4 steps kung singly bonded. Pero sa tingin nyo, yung central atom, hindi naman niya na-attain yung octet, then ipasok nyo, i-include nyo yung fifth step. You have to decide saan ka kukuha ng lone pair. If hindi parehas yung surrounding atom, then tingnan nyo sino dyan yung mas maraming lone pair. Siya yung pinaka-best na surrounding atom na pwede nating kunan ng lone pair, gagawin nating bonding pair or bond line. Okay? Now, for these examples, you try this, no, during your independent time study. Okay? Yung letter A, it may look complex but madali lang po yan. Among the given example, carbon would be the central atom. Okay? So, alam niyo na agad na yung dalawang fluorine, dalawang chlorine, these are surrounding atoms. And then you do the second step, third step, so on and so forth. Okay? Take note always nga kapag polyatomic ion, i-enclose dapat, 'di ba, ang Lewis structure in a bracket. Kapag ion, okay? Kapag ion lang.